As a semiconductor manufacturer, we at ROHM contribute to energy efficient and environment friendly solutions to address various challenges in the society by ensuring sustainable, quality and safe products for the end users. With an increase in demand for two-wheeler globally, electric vehicles are gaining popularity over IC engine vehicles due to low running cost per mile and maintenance. Electric vehicles also help in addressing the issue of rising pollution, global warming, depleting natural resources. Despite many challenges to address, electric vehicles are steadily getting traction in India with support of infrastructures and ecosystem getting better day by day. The crucial element of electric vehicles adoption is the driving range per charge depending on type of battery configuration. Lithium-ion batteries are standard in consumer electronics. They are the most popular rechargeable batteries with best energy to weight ratio, fast charging and low self-discharge rates with wide operation of temperatures. The high energy density helps to reduce the payload of batteries and increase the vehicle mobility. Fast charging is critical to reduce the vehicle's downtime of the commuter. Lower discharge rates help to retain the charge of a battery for a longer time, say in case of a vehicle in an unused state at a storage facility or home. In this session, we will introduce our battery management solutions developed for electric two-wheelers. Lithium-ion batteries has its challenges in terms of safety, and a good battery management system will ensure battery safety and maximum battery energy utilization. The primary function of BMS is to continuously monitor the cell and operate the battery within a safe operating area for voltage, current and temperatures. In addition, BMS provides protections against overcharge, over-discharge, over-temperature to avoid degradation of the cell, thermal runaway and deep discharge. The cell balancing functionality of BMS ensures each cell is charged or discharged to its optimum capacity. BMS also provides critical information about the battery such as state of charge, which indicates the capacity of the charge left over in the tank, state of health, which shows the present power of the battery as compared to a newer battery capacity. Let us look into the critical blocks of battery management system. The battery management IC is the heart of the system, which provides cell voltage monitoring and charge discharge currents along with multiple protections. In addition, it supports cell balancing by discharging the overcharged cells through a bleed resistor using internal or external MOSFETs. The low power MCU interacts with battery management IC to understand the battery status and manages the cell balancing function. The MCU also determines the battery parameters like SOC and SOH using either an external Coulomb counter or an internal algorithm. The battery pack current is measured using shunt resistors to ensure safe operating thresholds during charge or discharge operations. The pack connection to the load or the charger is managed by controlling the external charge or discharge MOSFETs connected in a back-to-back configuration, reducing separate harness overheads. The battery information can be shared with the user or uploaded to the cloud through Bluetooth, RFID and Wi-Fi interfaces. High voltage isolated DC-DC power supply supports the auxiliary power rails for the BMIC and MCU. ROHM supports a broad portfolio of products which include AFE, standalone, gate drivers, Coulomb counters, MOSFETs, shunts and communication modules to support various blocks of a battery management system. ROHM has a lineup of battery management ICs supporting applications like power tools, cordless vacuum cleaners, uninterrupted power supplies, energy storage systems and electric vehicles. There are two types of battery management ICs. They are a standalone which can manage the protection of the battery pack independently, and an analog front end has an extended functionalities with the help of a controller. Standalone and AFE ICs from ROHM supports minimum of 3 cells to a maximum of 16 cells. These can accurately monitor cell voltage, current and temperatures, providing output in an analog or digital format. The voltage accuracy offered by BMIC is best in class with a tolerance of plus minus 10 mV. They have low operating currents and offer as low as 0.1 microamp in their power down states. We have products with built-in cell balance functionality and external FET balancing as well. The AFE supports SPI or I2C communications with MCU. We support cascaded connection of battery packs from 5 cells to multiples of 16 to enable higher battery voltages. To meet functional safety standards, the combination of AFE and standalone ICs are used to duplicate the protections, wherein the AFE along with MCU can be used as primary protection for voltage, current, temperature and balancing. The standalone type can be used as a secondary protection for over voltage, under voltage, over current or short circuit and temperature detections. Let's have a quick look at the features of various standalone and AFE devices from ROHM. Standalone refers to an intelligent self-autonomous device. Let's look at one of its kind, ML5245. It is a standalone lithium-ion battery management IC that can support a minimum of 5 to 13 cells with low standby power, accurate over and under voltage detection rates of plus minus 15 mV. Other salient features include built-in short circuit and temperature detection function, MOSFET overheat protection to stop large charging or discharging currents through the body diode is an added feature. AFE variant ML5238 is based on the 80 volt wafer process which combines with MCU to configure its parameters, fault handling and communicate the battery status to the end users. The IC supports 5 to 16 cell with an internal balancing switch for each cell. Cell voltage monitoring function has an high accuracy of plus minus 10 mV. The current monitor function with selective gain multiplier provides flexibility in choosing sense resistors. Short circuit detection function with selectable threshold voltages is also available. The IC supports a built-in gate driver for controlling the charge and discharge FETs in a low set configuration. To address high voltage battery requirements with higher cell count, the advanced feature of cascading is supported by ML5239. With maximum of 16 cells and cascading of 16 stages, the cell range can be extended to 256 cells. The external FET control for the cell balancing enables to support higher balancing currents. Integrated 12-bit ADC minimizes the load on the MCU. The internal temperature sensing supports up to 4 channels of measurement. Self-diagnostic feature for the open or short detection on each cell port is available.
Lapis MCU is a high-performance CMOS 16-bit microcontroller with very low power consumption, high temperature operation and high noise immunity. It is rich in peripherals like UART, synchronous serial port, I2C bus interface required for communication with external devices. Successive approximation type AD converter are used for measuring external temperature and the voltages. On-chip clock with high accuracy of plus minus 1% and embedded power on reset function enable the removal of external resonators and reset IC to decrease the system cost. We have a large selection of MCU range that can be selected based on program size with ROM size starting from 16 KB to 512 KB. In addition, various packages like WQFN, GQFP and SSOP have a pin count ranging from 16 to 100 pins. The in-house integrated design, development and manufacturing system provides quality, stable supply. Lapis MCU offers approximate 10 years of longevity program. Considering the above features, these MCUs are popular in consumer appliances, industrial applications, and now we are extending the range to battery management systems. The MCU interacts with the BMS IC using serial communication like SPI, I2C to measure the cell voltages and detect any overcharge or over-discharge current. The MCU sets the parameters of the cell balance operation performed by the BMIC. The MCU controls the pack charging or discharging function by turning on or off the external FETs using a gate driver within the BMIC. In case of fault conditions, the MCU disconnects the pack from the load or charger, wherein contactors can be controlled to ensure complete disconnection. The MCU can also estimate the battery SOC with external Coulomb counter BD7220FV, indicating remaining battery capacity at 100%, 80%, 60%, 40% and 20%. The ambient temperature, pack temperature and MOSFET thermals are captured using internal 12-bit SA-type ADCs. 4 sleep modes are selectable, which helps reduce system power consumption, extending self-discharge time for cell packs. I2C communication is used for on-board LCD interface for a status update. Also, external EEPROM can be used to store and retrieve multiple battery configurations. UART is used for communicating with external GUI on PC to stream battery parameters like cell voltages, SOC and SOH. Coming to a very salient feature of Lapis MCU series has the safety functions to make a safe stop in case a failure is detected by executing the self-diagnosis software available to support IEC 60730, 60335 Class B by diagnostic test, error detection and memory rewrite protection. As the lithium-ion battery adoption is growing in the automotive, consumer and industrial segment, ROHM can provide one-stop solution with various products and address all blocks of battery management system. Power, greener and sustainable future with ROHM.